Hi, everybody. Welcome to Chapter 11's little review summary thing. So we're going to run through this pretty quick and hopefully it won't take too long. Remind you guys what we talked about in Chapter 11. So Chapter 11 was microbial control. So this is dealing with chemical and physical methods of controlling microbial growth. The terms that you want to be familiar with are asepsis, which is the removal of vegetative microbes from living surfaces. Disinfection, it's the equivalent for non-living surfaces. Decontamination, which is mechanical removal of microbes from inanimate surfaces. And then that can also, decontamination, I didn't update this slide, isn't just for inanimate surfaces. It's any surface that we're using mechanical for. So this can kind of overlap a bit with our asepsis or our disinfection, depending on if we are performing this on inanimate or animate surfaces. And then sterilization is the complete and total elimination of all microbes, including even endospores. So next were our terms relating to microbistatic and microbicidal. Remember that microbistatic puts the bacteria in stasis, so to speak, slows their growth or stops their growth, but it's not going to kill the cells, whereas microbicidal compounds are going to kill microbes. And if you hear these terms as far as like bacteriostatic and bactericidal, the same concept, but just for bacteria, right? So do be aware of all those terms. For physical, chemical, and mechanical means of removing microbes, the physical and mechanical aspect is going to include radiation that can within itself ionizing and non-ionizing radiation. Filtration, ultrasonic waves, we didn't talk about those, and then heat, which that can be moist or dry, or tyndallization, or pasteurization, or boiling. And then we have cold desiccation and osmotic pressure. Remember, osmotic pressure is going to be dealing with packing something in salt or sugar. Chemical versions that we talked about were the halogens that included the chlorines and the iodines. We did talk about other ones as well, like the fluorides and stuff like that, but we really focused our attention on the chlorines and the iodines. Then we had the phenols and the phenolics, the alcohols, the hydrogen peroxide and other oxides. We have surfactants, detergents, and the quaternary ammonia compounds, the heavy metals, aldehydes, gases, and we didn't really talk about the dyes in this chapter, and then acids and alkalis, which are going to change the pH and affect the function that way. So sterilization, usually when we are trying to sterilize something, we're going back into the physical removal of microbes. The best way to do this would be to use an autoclave, right? Remember, autoclaves are going to use heat and steam and pressure in order to sterilize. There's also the means of removing something via incineration, which is using dry heat, or even filtration, which is going to use a small pore filter to literally, mechanically remove microbes out of like a fluid or something like that. And we can use those to sterile if they is used properly. Ionizing radiation can also be used to sterilize. This causes the expulsion of electrons from like the bacteria or whatever. So we have the actual radiation coming, causing expulsion of those electrons, and then causing ions, and that causes disruption of the structure of a lot of the structure of molecules of the cell, right? That makes sense. So that will lead to damaging the actual atoms of those molecules, and that can lead to sterilization. Most things are not going to be resistant to that, and you can't block those. Ionizing radiation cannot be blocked with a barrier. Non-ionizing radiation, however, like UV radiation, is going to be effective at causing damage to nucleic acids, causing the like thymine and pyrimidine dimers, basically pyrimidine molecules to bind next to each other instead of across to their complementary pairs, right? And that can lead to mutation. That is typically not used to sterilize. So UV radiation is a non-ionizing radiation. We don't use it to sterilize. We can use it to disinfect. Other processes that can be used to make liquids safe for consumption include pasteurization, where we're going to heat a liquid up and then cool the liquid down and cycle over and over again. That maintains the liquid's integrity and preserves the flavor and things like that, but it will not sterilize. We use this for milk, so milk is not sterile. So halogens, including fluorine, chlorine, and iodine, these guys can be prepared to be effective for sanitizing. So we can actually and disinfection, but we can also sterilize using chlorine and iodines whenever we use them appropriately. This is going to include bleach. Bleach is included with that. Alcohols are good for destroying vegetative microbes, but have high evaporation rates. That can be problematic. Remember, you're going to want some water present whenever you are actually treating with alcohols, because the water helps with the coagulation of the proteins, and therefore the breakdown of the function of the proteins whenever you are treating. So you don't want to use 100% alcohol. You do want to have some water present there. And then we have the surfactants. This is going to include our quaternary ammonia compounds. These guys are going to disrupt our cell membranes because their amphipathic molecules will intercalate or squeeze in between the phospholipids of the lipid bilayer, and that will cause leakage out from the cell, as well as letting other things in, like chlorhexidine, which is a phenolic that is used in hospitals. So it will be more effective, and that's what we use as a surgical scrub. Hibiclens is used for that. And yeah, so that's a chlorhexidine scrub solution with a surfactant. Usually it's going to be a quaternary ammonia compound mixed there. Which is, like I said, a surfactant. I can't say that enough. And that'll allow other chemicals to penetrate the cell. Yeah. So we'll be able to poke holes in there and allow the chlorhexidine to get in. So that's the basic rundown. Obviously, there's a lot more to go over as far as what was covered in this chapter. I don't know how to just cover it without just rereading the whole chapter. But these are some of the main points for this chapter, and I will, I guess I'll see you guys soon.